Let me introduce myself again. I'm Yushan. I'm PhD student in finance from the Econ and Finance department. Welcome to this first review session of Finance 3000 class. Okay, so today I will prepare chapter 2 to 5, but I'll start from chapter 5 because it's relatively more important. Okay, I will go over some important principles that you should know for this chapter and also for other chapters when there are math and time value of money are involved. Okay. Okay. Start from very beginning. The first principle is what? $1 today is now equal to $1 tomorrow, right? So we can never compare two cash flows or two investments which happen at different points of time. We have to bring them together to a same point of time and then make the comparison, right? We either can convert them to a present value or convert to them as a future value, right? But the principle is bring them to the same point of time and do the comparison, okay? So that introduces the first two concepts, future value and present value. Okay, future value is pretty simple. It's a value that is measured at some future point of time or later point of time. And present value is some value that measured that we look at more closer to now, more closer to the current point of time, either now or some earlier time relative to the point when we are doing future, right? So the present value is at a more earlier point of time, and future value is at a more later, more future point of time, right? And how to calculate, how to transfer the cash flows, the value of the cash flows across the timeline, okay, between the future value and the present value. We do interest, right? We calculate interest. We calculate using, we could either discount or compound, okay? There are two methods of calculating for interest, either simple interest and compounding interest, right? Let's quickly go over that. What is a simple interest? So interest only generated from the principal, right? Not from previous interest. But for compounding, interest is generated not only from the initial investment or initial principal, it is also generated from previous interest, okay? So a very simple example, 6% interest rate and annual, okay? The beginning balance is $100. The interest earned each year is just $100 principal multiplied by the interest rate, 6%. So the interest rate is $6 always, okay? 5 years, say it is a 5-year investment. And the balance at the end of the year is just the balance at the beginning of the year plus the interest earned at that year, okay? Say 106. And another $6, another $6, another $6. It's a linear, right? Linear relationship. It's neither increasing in the balance, account balance. So that's pretty simple. The future value of a cash flow that's calculated using simple interest is just the present value or the principal plus principal multiplied by interest rate multiplied by number of periods. So this is $100, 6% in 5 years. How many? 30, right? $30. 100 plus 30. So the future value is $30. And these are the you can transfer into calculating for present value or future value. Pretty much the same. But for compound interest, we are generating interest out of both principal and interest. So the example is changed a little bit. Okay, the beginning balance is $100 same. And the first year, the interest is generated from the principal and previous interest, but there is no previous interest. So $6 interest. And the balance, 106. It's also becoming the beginning balance of the second year, right? So second year interest are generated from the beginning balance, which is $100 plus the interest generated in the first year. Okay, again. So that's the interest generated from second year. Right, it's pretty much the same, right? So ending balance becomes a beginning balance and generate the interest again. So the balance is a little more than 130, okay? So that is a formula. The future value of a cash flow is the present value multiplied by 1 plus r to the power of t. T is the number of periods, okay? And we can simplify the expression to that, okay? And present value is just a future value divided by 1 plus r to the power of t. Okay, that's the two very basic formula or equation we learned, right? Starting from chapter 5. All right. What do we call this method? We call them discounted cash flow method. Okay, the cash flow are discounted or compounded along the timeline, right? Okay. Some terminologies. Discount rate. What is discount rate and what is discount factor? We call that R, the interest rate, the discount rate. And 1 over 1 plus R to the power t as the discount factor. Okay, discount factor is just the value of $1 that happened in t periods and how much that is valued right now. Okay, say it's 6% and 5 years later, and $1 that happened 5 years later is equal to this much. 1 divided by 1 plus 0.06 to the power of $5 at the current time. Okay, right. So discount rate and discount factor. To find the value at some future date of stream of cash flows, calculate the future value of each cash flow and then add up these future values. That is saying if we have a very complex cash flow or even a simple cash flow, but with periodic multiple cash flows, right, multiple ones, we can use this formula to calculate either the future value or the present value for each of those cash flows to a same point of time, and then add them up. Okay, that sounds pretty complicated, but we got what? We got a calculator, so things become much easier than that. But what's happening in your mind should be that we are calculating the future value or present value of each cash flow to the same point of time and add them together. Okay, all right. Everyone has your financial calculator? Okay. Let's just go over some buttons. Let's look at the function of these buttons in it. Okay. Let's set up this example. So let's say it's n years of investment time periods. Okay, n years, as the compounding frequency is m. What does m mean? So it could be annual compounding, right? It's a semi-annual compounding, or quarterly compounding, or monthly compounding. So how many times does a cash flow is a cash flow compounded within 1 year? Okay, right. So if it's annual compounding, you could just one compound, and semi-annual, so 2 times, or twice, right? And quarterly, 4 times, monthly, 12 times. Okay, and let's see how these buttons are defined. Okay, on your financial calculator, these are 5 most familiar buttons to us. So N, IOI, PV, PMT, and FV, right? So N is not the number of years, it's not the number of months, it's defined as number of periods, okay? Number of individual periods that is compounded, that is used to compound. Say it's a semi-annual compounding, so N should be the number of 6 months, right? The number of half years. Or say it's a quarterly compounding, the N should be the number of quarters. So that is equal to what? Number of years multiplied by the frequency, compounding frequency, right? Say it's a 5-year investment with a quarterly compounding. How many periods in total? Yeah, 4 multiplied by, let's say 5 years, right? 4 multiplied by 5, okay? So it's 20 periods, okay? All right, and IOI is the interest rate per period. It's not annual interest rate, it's not like a semi-annual interest rate, it's per period. The interest rate that's actually happened for that specific individual period, okay? So it is the APR, we all learned that, right? It's stated, nominal stated interest rate, okay? Divided by number of periods in each year. Say the stated interest rate is 6%, and it's a semi-annual compounding, so IOI should be 3, yeah? Right, okay. PMT is the amount of periodic payment, right? Recurring payment. You're gonna use that very frequently in bond evaluation chapter, because the bond pay coupon, like periodic same amount of coupon for every period. You're gonna use that a lot. Okay, and we all know what PV and FV means, right? Okay, PV is a value at a closer point of time, and FV is at a more future point of time. do not ignore the signs. Okay? Do not ignore the directions of cash flow. When actually doing directions, keep in mind what are the cash outflows or what are the cash inflows. If you ignore the signs, you will get the error warning, right, on your computer, on your calculator. You cannot get the correct answer. So my suggestion is just, okay, for cash outflow, put a minus sign in front of the number, right? So present value says it's an initial investment, and then you are getting cash inflow. Put a negative number in front of the present value. Okay, so that makes otherwise you cannot get the answer at all, right? Okay, so put a negative number in front of any cash outflow. Okay, all right. There are different types of cash flows. Simple ones is one cash inflow and one cash outflow, right? But could be very complex ones, and we learned two complex, little more complex streams of cash flow. Annuity and perpetuity. What is annuity? A same amount of payment that happens for a finite period of time, right? But if it's an infinite period of time, we call that perpetuity. Okay, same amount of payments. Okay, all right. So present value of perpetuity is just periodic payment divided by the interest rates. Okay, okay. The derivation of this this function could be very complicated, but finally we got a very clean and simple equation: the periodic payment divided by interest rate. Say we're getting $6 per year. $6 per year with the interest rate of, say, 6%. How much is that value? 100, right? 6 divided by 0.6 gives $100. That cash flow is equal to, the present value of that cash flow equal to $100. The present value of future value of annuity can be calculated using financial calculators, using the function that we just mentioned. Right? We're going to do a lot of exercises today, okay, on our question list. Annuity due is just a little different than ordinary annuity. Okay, ordinary annuity or annuity, each cash flow happens at the end of the period. Okay, so that means the first cash flow happened in one period later, not now, okay, not current time. It's one period later. Okay, and the second happens at 2 periods later. But if it's annuity due, the first payment happened right now, okay, instead of 1 year later, right now. Okay, and the second happens 1 year later. So each payment is 1 year earlier for annuity due than ordinary annuity. Okay? And the present value of annuity due, if we know the present value of annuity multiplied by 1 plus interest rate, we get this present value or future value. Why is that? Say for each cash flow, okay, of ordinary annuity. Let's say just one cash flow that happened 1 year later. Okay, its present value is what? Is that cash flow divided by 1 plus R, right? It's discounted by 1 period. But now let's say it's annuity due. It happened right now. We don't discount. Okay, we got that payment, $6. We got that $6, right? We don't need to discount any present cash flow, right? So the value of annuity due is worth 1 divided by 1 plus R for the annuity, multiplied by 1 plus R, just 1, right? So for each cash flow of annuity due, it is discounted by 1 less period than ordinary annuity. Can you follow me? For each cash flow of annuity due, it is discounted by 1 less period than an ordinary annuity. Let's draw a timeline. If you get confused and not only what is going on, we can always draw a timeline. That's my recommendation. Say we have, make it a little complicated. 2 periods, okay, 2 periods and 2 cash flows. T equals 0 meaning current time. And T equal to 1 meaning 1 year later. That is what? That's the end of the first year or the beginning of the second year, right? And T equal to 0 is the beginning of the first year. Okay, T equal to the beginning of the third year or the end of the second year. Let's say $6 $6. That's annuity, right? Ordinary annuity happens for 2 years, 2 payments. And let's say interest rate is 6%. Get that present value. You can just calculate it by, so manually, right? So the first payment is $6 divided by what? 1 plus 0.6, okay? And the second, 6 divided by what? Squared, right? Squared. Okay, that is the present value of ordinary annuity. Let's say PV1. Now, if it is annuity due, the cash flow become like this, right? $6 at the beginning of the first year and the beginning of the second year. So the present value is what? 6 plus, right? That's the 6, right? And plus the 6 divided by 1.06. So you can see for each cash flow, they are discounted. It is discounted by one less period. This is this $6 divided by 1.06 divided once. Now it's divided by 0 times. And this is divided by twice, discounted by twice, but now only once. So if we add them together, so PV2 is 1 plus R multiplied by PV1. It's exactly what we see here. Okay, present value of annuity. Okay, if it's discounted by one less period, so it is valued more, okay, by a factor of 1 point R, by 1 point interest rate.
Confused for annuity due, right? It's just the 6 plus 6 over 1.6, and you don't do the third cash flow?
There's no third cash flow. There are only 2 cash flow, right? Only 2 cash flow.
Right. This is you're beginning with 6, so there's not going to be another one that says 6 plus.
No. You mean here?
Yeah.
No, here's not. So annuity due and comparable annuity due and ordinary annuity, they have the same number of payments, but happen at different point of time, right? So we just move each payment forward for 1 period, right? Move this forward by 1 period, and move the second forward by 1 period. If you move it forward by 1 period, move to relative to current time, you discount that number, okay, by 1 less period. It used to be discounted by 1 period, right? 6 divided by 1.06. But now it's becoming it's a current number, 6. We don't discount it, right? Question, ask questions. I see confusing faces. Right, okay?
So for ordinary annuity, you say you discount a period?
Discounted.
Period of payment?
Yes, right. So for each period, for the ordinary annuity, they all happen in the future. Meaning future means what? We need to discount it to a present value, right? And depending on when it happens, we discount by a corresponding number of periods. The first $6 happened at t equal to 1, discounted by 1 period. 1 plus 6, 106, right? Question?
So let's say that I want to know instead of the first, the annuity due, for the 0 number, I want to know the number 2.
Right here?
No, I want to know the value. Okay, I want to know the value of T1 on annuity due. I will use whatever I have there at that point, and then do it.
You're saying annuity due or ordinary annuity?
Annuity.
Annuity due?
I always need to use the 0, the beginning of the $6.
The $6, right? There are 2 cash payments, right? One happened at t equal to 0, the second t equal to 1. If it happens at t equal to 0, it means, okay, it happened right now. The value of that $6 is just the $6, right? And the second happens 1 year later. So 6 divided by 1.06. Yeah?
So that's ordinary annuity or annuity due?
Annuity due.
Because it's starting from today.
Starting from today.
Okay.
Due, right? Due is what? Homework is due. So yeah, okay, right. If you cannot just understand what's really going on, this formula is very easy. Keep it in mind. So annuity due, cash flows happen earlier, right? If someone promised you an investment that with cash flow happening earlier than later, you would give it a higher value, right? Someone promised you, I will give you $100 today rather than 1 year later, you want to get what? We're going to get today, right? Because it values more for you. You don't need to wait for another 355 days, right? So the same cash flow. But the one happened earlier, the other happened later. You always give the earlier one a higher value, right? By how much? Keep that in mind. 1 plus R. Okay. Right. If that is easier to remember. Okay. Future value. I won't spend time doing that. It's even more complicated. You can just keep it in mind. All right. The first future value, same thing. Okay, same thing. I wouldn't explain this. It's going to be even harder. It's going to confuse you even more. Okay, so just keep in mind the present value and the future value of annuity due is always higher than this ordinary annuity by a factor of 1 point R. Yeah.
Questions that are annuity, annuity due, so we can see like a distinct.
Hopefully we can do that. At this speed, it's going to be. I would say finishing chapter 5 would be. I would be satisfied. I mean, I think we don't have enough time for the other 4 chapters. So if you want to, right.
So for chapters like 2 to 4, isn't it more conceptual? So we can
This
just
is completely conceptual, right?
So we can just read.
I know for chapter 4 there are many ratios and right, many ratios and equations. Do the professor give you cheat sheet?
For the first midterm, yes.
Some yes, some no. If no, I will show you a table with all the functions. Keep that in mind. Just remember all these equations. It's tedious. I think it's a waste of time to clearly analyze or remember what's going on. Just keep it in mind and use it correctly. Okay? Yeah.
For the first midterm that I took, she allowed us to like write our own formula to use it during the test. Is that the same that's going to happen with the final as well, or you?
I don't know. Final is departmental, right? Depends on.
Be given a formula sheet. Or
We will know maybe next session. We will know. Yeah. Yeah.
Are you going to share this information with us on Blackboard?
Sure. I will upload this to Blackboard and answer key and yeah. Right. Question. Okay. We need to speed up. It seems okay. 2 hours is far from enough for us today. So okay. Expression of interest rate. Now we are doing APR and EAR, right? You have already learned this, right? So EAR, okay? EAR is the interest rate that is annualized using compounding interest. Both EAR and APR, both EAR and APR are all annualized return, okay? So say, people will ask you, okay, the EAR for a 6-year investment or the EAR of a 1-year investment. That 6-year or 1 year is totally irrelevant. EAR or APR just annual, just within that 1 year. It's irrelevant with how many years you are talking about. Okay, they are all annualized, annual interest. The difference is the EAR is calculated using compounding interest, which is more realistic, right? It's more realistic in banking when you are owing some debt and you have a line of credit owing the banks. That's how interests are calculated. It's compounding interest. And APR is interest rate that annualized using simple interest. And once we know how the frequency of compounding, we can convert. Okay, we can convert between these 2 measures. And how to convert? So that's the formula. All right. 1 plus EAR is equal to 1 plus APR divided by M. M is what? Compounding frequency, right? Either 1 or 2 or 4 or 12, right? Depending on how the cash is compounded within 1 year, right? Okay. I won't explain this too much, but because we got a function of financial calculator, we're going to use that to calculate that number very easily, convert between these 2 numbers very easily. Okay. Right. And we got this question. We got this similar questions on our question list. We're going to do that. Inflation. I think you have learned this on Econ 102, right, Professor Malcolm? Yeah.
Posted online?
Yes.
Okay.
Yes. And the link of this lecture, all the questions you asked, all the answers I gave will be available on YouTube. All right. Sounds cool. Huh? Okay. So inflation is the rate at which prices as a whole are increasing. But how to measure prices? We got many different price measures, right? Price index, if you can remember, GDP deflator, CPI, right? So in this textbook, we are using CPI as a measure of price levels, right? So inflation rate is just the percentage increase in the CPI. Okay. Why does that matter? Because someone may promise you, okay, you make $1 investment today, and 1 year later, I will give you $6. That's 600% return, right? May sound very attractive, but how about the inflation in that year is 700%? 700%. That meaning what? Even though you get a 600% nominal return, the actual purchasing power of the $6 you earn at the end of year is even less than $1, the purchasing power of $1 today. The purchasing power of that $6 is eroded by inflation, right? So sometimes you want to know the real return instead of the nominal return, okay? So what are the real return of real dollars? What are the real or the nominal dollar or nominal return? Current or nominal dollars versus constant or real dollars. Current or nominal dollar refer to the actual number of dollars, just how many dollars, right? And constant or real dollars refer to the purchasing power. So when you are measuring your return from an investment, you may be more likely to calculate real return instead of nominal return, right? So nominal return on nominal interest is the rate at which money invested grows, okay, just money. But real interest rate is the rate at which the purchasing power, the real value or constant value of that investment, okay? And how to calculate your real return? Let's say an investment promises you 6% of return. So the nominal interest rate here is 0.06. Okay. And let's say the inflation rate in that year is 2%. Okay, not very crazy, 2%. So the inflation rate of 0.02. Then you can using this formula to calculate the real interest rates, right? That's the only unknown variable here. Okay. There are multiplication between two terms. It seems a little complicated. You can simplify that into an easier form. It's approximately equal, not exactly equal. It's approximately equal to, okay? So 6 is equal to real interest rate plus inflation rate. Okay? So that is how much? 4. Okay. Therefore, if an investment promises you, okay, I'll give you 6% annual payment, annual return, and you expect that the inflation rate is 2% in that year. So your real return or the actual return that you get from that investment is just 4%. Okay, that is the actual increase in your purchasing power that you gain from this investment. Okay, right. Question.
So these two are equivalent, right? Those two formulas.
They are equivalent. And slightly different. That is an approximate number, but it's accurate enough for us to draw a conclusion on how much purchasing power we actually gain from this investment, right? So that's why we have an approximate equal, not exactly equal, slightly different. Yes?
About the inflation rate,
Yeah.
do we use the number like present inflation rate or future expected inflation rate?
You mean the present inflation rate or the expected inflation? That's a very good question. I would say a future one, because your cash flow happen in the future, right? And it's discounted from a distant point of time to the current, and you care more about what's the inflation rate right there, right? Instead of what is actually going on right now, right? Okay. Yeah. Current dollar cash flows must be discounted by nominal interest rate, and a real cash flow discounted by the real interest rate. Okay, right. So just use the corresponding interest rate for the corresponding cash flow. If that cash flow is a real dollar, okay, you discount it by the real interest rate. If it's just a nominal dollar, or you just discount it by the nominal stated interest rate. Okay. And read the question carefully. If you have these similar questions, read those terms carefully. Are they nominal? Are they real? Okay.
Are you going to give examples for this?
I think so, but I'm not sure. There are so many questions. Let's say if at the end of the session you still have questions, let's discuss. Okay. Yeah. All right. So it's time to do questions. Time to do questions. But if I have a slideshow, okay, it's very ugly. So let's just. All right. Let's just put everything here. Okay. We don't do those animations and those fancy things. Okay. Can you see it?
You can put it right up a little. Put it right up a little. Up. Yeah. Right there, right?
Good idea. Okay. All right. Because I want to write something on this, I don't want to put down to the screen. Okay. Okay. The sum of $300 deposited into an account paying 10% annually. Okay. So it's annual compounding. M equal to 1. Right. And if $1,206 is withdrawn at the end of year 1, year 2, how much remains in the account at the end of year 2? Okay. So first thing first, I would draw a timeline and see what's going on. So there are 2 periods. All right. We deposit $3,000 right now. Okay. So here there is a cash outflow, right, from us. And then at the end of the first year, there is a inflow. And at the end of the second year, another cash inflow. So that's the cash flow. 3 cash flows: initial $3,000 investment, and 2 periodic payments: $1,206 at the end of year 1 and at the end of year 2. Okay. And then interest rate is 10%. Number of periods is 2, right? And then we can use the calculator. Let's do that together. Work on your calculator. Let's do that together. So there are 2 years. Okay, 2 n equal to 2, and the interest rate is 10. Wow, that's really. Okay, interest rate equal to 10. PV is our initial investments. Okay, $3,000 negative. And there are 2 payments for each period. How many periods? 2 periods. And calculate future value. Okay, 1097. So, all right. The default setting in here, PMT, is what? Is that the periodic payment, the payments happen at the end of each year, right? At the end of each period, with the first payment happening at the end of the first period. Okay, we're going to do some other ones when it's happening in the first period, at the beginning of the first period. Okay. So starting from number of periods, I wrote something here. So 2. Okay, click 2 and click N. And then interest rates, 10%. IB, right? And PV, $3,000. Let's not put a negative sign. Let's try not. There is no negative sign. Let's see what we get. Which is wrong, right? And calculate. Very ugly number. What it means? What does it mean? It's not correct, right? Because we ignore the direction of cash flows. The $3,000 is not an inflow; it is an outflow. Put a negative sign on it. Compute. Huge. No, if it is only if it is a cash outflow, as a negative. This is a cash outflow. You deposit something, right, out of your pocket, right? So that's like outflow. Only put a negative sign in front of outflow. Okay. Right. withdrawal you get, you obtain, right? It's the inflow. Right. Deposit into a bank is not the inflow. Your pocket is inflow, right? You put anything out of your pocket into an investment, into a security, into a bank account. These are outflow, right?
So if you deposit a check into a bank, that is not your inflow.
Not inflow. You are investing in something. You are putting something outward, right? Instead of putting. But that's your account. That's your investments, right? Okay. All right. Okay, that's just the beginning. Let's try present value, right? What is the present value of an annuity, the ordinary annuity of $27 received at the beginning of each year? Oh, that's not ordinary annuity, right? Received at the beginning of each year for the next 6 years. The first payment will be received today. Okay, annuity due. Right? That's the definition of annuity due.
So if the payment is at the beginning of the year, and then annuity due at the end of the year is ordinary. If it's the end of the year, it's ordinary.
Right. Yep. Yep.
So that's the only difference.
That's the only difference. Interest rate, the amount of each payment, number of periods, all the same. Yeah.
What if there's a payment in the beginning of, like there's one payment that is in the beginning,
right,
but every other payment is at the end of the year? Is that still considered annuity due, or?
That's still annuity due, but you are expressing the cash flow in a little different way, right? The end of year is also the beginning of another year, right? So you just have to say the first payment beginning at the first of the year, and all the other payments, including the second one, right, happen at the end of the first year. But aggregating this whole thing, you are observing that each cash flow is happening at the beginning of each period, right? Yeah. Right. Question. $27, 6 years, received at the beginning of each year. Okay, and the first, and discount rate is 10%. Okay, there are many ways to do this, and I believe your professor gave you various approaches to do this question. And let's try one. Let's try one. And if you have other methods, raise your hand and we will discuss. Okay, so setting the payment setting to beginning of the period. See if you know this. Second, PMT. End means what? Cash flow happen at the end of each period. Second, set. Now it turns beginning. So those now, see the BGN, now PMT happen at the beginning of the period, not the end. Okay? Then we can do the calculation. How many of you know this? 1, 2, 3, 4, 5. Okay, good. Okay. We'll try another one. We'll try another method. Okay. Let's do this first. So there's 6 years, 6 periods. Interest rate is 10. PV we don't know. We are calculating for PV. PMT 27. Future value is known. Any terminal cash received? No, right? They're all periodic payment. Okay, there's no future value. Okay, all periodic value, periodic payments. Calculate PV. It's about 130. Okay, it's about 130. This is how we do it. Second PMT. Second PMT. Second enter. Now we turn it back to end. If you want to use this method, do not forget to turn it back. Otherwise, 20 questions after this question will be answered incorrectly. You get nothing from it. You get a wrong answer for all of them. Okay, turn it back. It's extremely important. I forget. Okay. Okay. It's sound a little strange, right? Okay. Yeah.
We didn't do negative 27 PMT. You didn't do negative 27 quickly.
How do we get it?
How come you didn't do negative 27 PMT?
Negative 27. That's received, right? The received. the inflow. You are receiving money. If you are not comfortable with this method, let's try another one. Now we turn everything back. Remember the formula? The present value of an annuity due is equal to 1 plus R multiplied by the present value of ordinary annuity. We can just consider this as ordinary annuity and get the present value and then multiply by 1 plus 10%, right? 1.1, right? That formula. We can use that formula. So we don't change any setting. Let's just consider. Let's just assume it's an ordinary annuity. All right. So 2 periods. No, not 2 periods. So 6 periods. Okay, and everything the same. Everything are the same. Instead of that setting, right? 10 and 27 and 0. Okay, and we got this. Okay, yeah, they got this. And that's the present value of ordinary annuity. Now we want to convert it to the present value of annuity due. Multiply it by 1 plus R. 1 plus 1.1. So same answer. Use whichever one you are more comfortable with. That's the 2 methods I know. If you know other methods, you can let me know. Right. I personally think the second one is safer because you don't need to change the settings again and again. It's very risky. Just in case you forget to turn it back. Okay, that's one. Question? All right. Okay.
The normal setting of the calculator is
end.
At the end?
Yeah, the end.
Oh, I thought it was the beginning.
Yeah, because and you never see anything here. There's nothing in here. If it's beginning, it's going to show BGN here at the top of the screen. All right, next one. Okay, the answer is A. Oh, this one is even more complicated. Charlie wants to retire in 30 years. Okay. He wants to retire at the end of the 30th year, okay? And he wants to save an annuity of $1,000 a year for 20 years after retirement, okay? Charlie wants to receive the first annuity at the end of the 30th year, okay? Again, very complex cash flow. Let's draw a timeline, see what's going on, and then do the calculation using our calculator, okay? So the timeline is, so first we have to wait for 30 years. Okay, t equal to 0 is the beginning of the first year. T equal to 1 is the end of the first year. So that means t equal to 30 is the end of the 30th year, right? T equal to 1, the end of the first year. T equal to 30 is the end of the 30th year. Okay, let's put some other. Okay. Right. Charlie wants to receive the first annuity payment at the end of the 30th year, and that is $1,000. So let's see here. Okay. And $1,000 for each year, and that lasts 20 years, right? 20 years. Okay, and keep going on to what? If your first payment is it's equal to 30, and there are 20 payments, so the last one should be what? 50. Let's say, yeah. Let's count like 50 or 49 or 51. So let's draw 49 and 50. Okay, 30 is the first one. 31 is the second one. Okay, it's the second one, right? How many? Which one is at the end? Last payment. 49, right? 49. Okay, that's the importance. That highlights the importance of drawing a timeline. I can't make these things work in my brain. I have to draw a timeline to see what's going on. And there are in total 20 payments. Okay, 20 payments. All right. Okay. interest rate 10%, how much must Charlie invest today in order to have his retirement annuity? Okay, how much? These are the cash inflows. How much does he have to invest right here in order to get the value of those 20 payments? Okay, that means we need to convert those value to a present time. Right? We need to calculate for the present value of these 20 payments. Okay, many methods to do that again. Okay, there are many methods. I will say one. If you have other ones, we can do it together. Right. So that is annuity, and we know how to calculate the present value of annuity. Right. Say if it's as annuity, we are standing right here. Let's say we are standing right here, and we are evaluating the present value of those 20 cash flows as of this date. What do? We use a financial calculator. Okay. See this? The value at the beginning of the 30th year is t equal to 29, right? The present value of those 20 cash payments, cash inflows, as of t equal to 29. We can use the calculator, right? 20 years, interest rate 10, $1,000, 0 future value, and get a present value. Present value is as of here. We got, okay, its present value is $5,013, 5513. Yeah.
N is 20.
What's that?
Why is N is 20 there?
And 20. 20 payments. Yeah, there's 20 payments. Right. Okay, that's the value as of this time. It's not the value as of this time. So we still need to discount that single value that happened at t equal to 29 to t equal to 0, which is pretty simple, right? That's just one cash payment having in the future, and turn it back to the present value. Okay, n equal to not 30, it's 29, right? 29 to now, it's 29 years, right? T equal to 1 is the end of the first year. T equal to 29 is the end of the 29th year. Then we're counting, well, just keep counting numbers in here. Just if you in a real exam do this very quickly, you can make mistakes very easily. I sometimes just cannot figure out what's going on. So n equal to 29, not 30. So interest rate 10 and just one single future value, right? And there's no periodic payments in between 1 to 29, right? And calculate for present value. Okay, it should be some number around 540. Okay, good. Question. Is this question hard? It is considered to be a hard one. If you happen if it's having your real exam, yeah. Why is a negative or?
I thought 8,500.
You mean right here or?
Yeah, the answer for the present value.
Yeah, it's not that. It doesn't necessarily be exactly the same number. Do you get 8513? Okay, then never mind. These are just approximate decimal numbers, right? 40. Okay, you need to look at what's going on, right? Otherwise, do you get a similar answer here? Am I making? I'm not sure. Okay, if everybody, yes. Why is N29 here? Because that 8513 happens at when? At the end of the 29th year. A payment that happened at the end of the 29th year. You want to convert it to present value. How far is it away from here? 29 years. T equal to 1 is the end of the first year. It's 1 year from now. T equal to 2 is 2 years from now. T equal to 29 is 29 years from now. So n is 29. So 29 periods from now, right? Yeah, Question?
Would this be considered an ordinary annuity?
This is considered ordinary annuity. Some others may think this could be also annuity due, right? Right. But depends on you. That's how I want to give you two methods different and confuse you. This is the easiest way to think about it. Otherwise, you can think of it as annuity due and change the years a little bit in here, around here, right? Not instead of calculating the value right here, you can calculate right here, right? If you're calculating the value right here, you are considering this as annuity due. But no, let's not do that. Let's just consider it as the simplest case, ordinary annuity. Yeah.
You can do it either way, right? However, when you get to 8513, how did you get 540? I think that was her question.
No, these are two steps. These are not two methods. These are two steps. Two steps to get the 540. Yeah. We plug in that 8513 into future value in the second step, and get the present value. Yeah. That's not two alternative methods. Yeah. That's your question? Yeah. Okay. Yeah. All right. Okay. Question. All right.
Well, in the problem it says that Charlie wants to receive the first annuity payment at the end of the 30th year.
Yes.
I still don't understand why we're calculating for the 29th year.
Because you think you should calculate at as of t equal to 30 to equal to instead of 29. You can. I mean, you can. But we are considering this ordinary annuity, right? Whenever we are calculating value for ordinary annuity, you remember this case? Ordinary annuity, the first payment happened 1 year later, 1 period later. And if we are calculating the present value for that ordinary annuity, we are calculating the value as of here, which is 1 year earlier than the first payment. Okay. Say these are an ordinary annuity. Now we're saying, okay, the present value of ordinary annuity. We are assuming that we're calculating that present value as of 1 year earlier than the first payment. Because remember the definition of ordinary annuity. Ordinary annuity is a stream of cash flows happen in the future with the first payment 1 year from now. And you want to get the present value of that. So that's the present value as of 1 year earlier than the first payment. Now we have 20 payments. With the first payment made at t equal to 30, now we are calculating a present value. So naturally, we are calculating the present value as of 1 period earlier than the first payment. So it is as of here, right? I know, yeah, I understand. It's hard to understand. You have to get used to this, this timeline language and the definition of that security, right? You should be aware of what you are calculating for, even from the simplest one. We went over the simplest ordinary annuity question. That's actually the same thing, right? The first payment is at the end of the first year, and we're calculating present value at the beginning of the first year. So that's 1 year lag, okay? Right. All right. No more questions? Let's move on. All right. These are mortgage questions. You are getting a mortgage, but with two deals, the different. Yeah. Question number 38. 38. Let's move it up. Okay. Two mortgages with the same initial borrowing amount, $250,000. Okay, but one has a 30-year maturity, interest rate of 5.65. Right? The other one's 15 years and 4.9%. Okay. How much more in total will you pay if you select this rather than that? So actually you pay. Okay. Let's first calculate what is your periodic payment. So for a mortgage, we all know how it works, right? We borrow some initial loan and make a periodic same amount of payment for n years. And at the end of the n year, nth year we pay off the whole loan, right? The amount of loan outstanding is becoming 0. Okay, so there's initial loan amount, and then there's n periodic, same in periodic payments, and we pay off the loan. Okay, same thing here. One is 30 years, the other is 15 years. So first, let's calculate the PMT or periodic payment for the first mortgage. Rounding the monthly payment, right? It's monthly payment, so it's monthly compounding. Okay, so when you are thinking about, okay, how is it compounded? You look at how the payments, what is the frequency of the payments? Okay, the payments is so our monthly payments, so it's monthly compounding. 30 years, monthly compounding, and multiplied by m, so it's 12 multiplied by 30, so 360. Interest rate, same thing, right? APR, 5.65 divided by m. M is 12. 5.65 divided by 12. PMT initial loan 25,000 to 250,000. PMT we don't know. Future value is 0. We pay off the loan at the end of 30th year. So the payment is 1,443. That's a periodic monthly payment, right? And how many payments we made? 360 payments. Okay, that's a little weird, right? We are calculating the total instead of the present value of that cash flow. We're calculating the total payments we make in those 30 years. So 1443 multiplied by 360. These are the total amount of payments we make, okay, for that mortgage. Same thing for the other one. 15 years multiplied by 12, 180. Okay, 4.9 divided by 12, same thing. Okay, and multiplied. Okay, first one minus the second one. So that is the difference of payments between the two methods. Okay, right. What is the present value of the two payments? The present value of these two payments are just $250,000, right? The present value of $250,000. That's your loan, initial loan. You are making different payments because the maturities are different and interests are different. Interest rates are different. Okay. All right. Question? No? 39.
Step off.
Okay, good. 39. So assume the total expense for a current year in college equal to $30,000. Okay, the total payment for a current year. How much would your payment have needed to invest 21 years ago in an accounting paying 5% compounding annually to cover this amount? So now, okay, you need $30,000, and your parents make a deposit 21 years ago. So that $30,000, even though it says as of today, it's a future value, right? As of the actual day when you make the investment. So 30,000 is the present, is the future value. Okay. 5% interest rate and 21 years. Simple enough. Calculating for PV. Okay. Okay. That is the value of the deposit 21 years ago. Okay. Good. Annual, that's not. That's annuity. Annuity is a stream of cash flow, right? There's one single cash outlay and one single cash withdrawal.
Just present value. Right?
Just present value, future value. Annuity, perpetuity, or growth perpetuity, these are stream of cash flows, right? Yeah.
So in order to make it like annuity, would it have to say how much would they have to pay each month?
Each month,
okay.
In order to, each month. I think I do have. Let's see. Okay. So the bank paid 3% annual interest rate on saving accounts. If you deposit $2,700 in the bank and leave it there, assume the bank pays compounded interest rate, how much interest will you earn in the first year? How much interest you earn in the second year? How much interest you earn in the 10th year? Okay, it's compounding method, right? And as annual interest rate, we don't see it is like a monthly compounding or quarterly compounding. So we just assume it is annual compounding, right? There's no information on how it's compounded. Just we assume it is annual compounding. So okay, well, how much interest you earn in your first year? It is your initial balance at the beginning of the first year multiplied by interest rate, right? So you deposit that amount into the account, and it earns 3% interest in the first year, so $81, right? That's pretty simple, right? And it's a little more complicated is the second year's interest. So second year's interest is earned from both the initial investments, initial deposit, $2,700, as well as the interest you earn from the first year. So that is $2,700 plus 81. Okay, you earn interest on top of that, multiplied by the interest rate, which is equivalent to that. Why is it equivalent to that? Because 81 is what? Is 2,700 multiplied by 0.03, right? And we'll pull that 2,700 out of the parentheses. Okay. It's equal to 2,700. No, 100 multiplied by, right? Pull that 37 out of the parentheses. Right? Right? 81 is equal to that, and we pull the 2,700 out of parentheses. So 1 plus 0.03, which is 1.03. Okay, multiplied by 0.0703, right? Exactly that. Okay, yeah.
Would this PowerPoint with the solutions be accessible?
Yes.
Yeah. Video.
Yeah. All right. So now things become even more complicated. The interest you earn in the 10th year. So interest you earn in the 10th year is equal to your initial balance at the beginning of the 10th year multiplied by 0.03. But what is your balance at the beginning of the 10th year? 2,700 multiplied by 1.03 to the power of 9. At the beginning of the 10th year, your initial balance has been compounded for 9 years, right? This is compounded by 1 year. Now it's compounded by 9 years. And we earn interest on top of that total balance. Yeah?
So if let's say they ask at the end of the 10th year, would you use 1.03 to the 10th power then?
Well, this is the end of the 10th year, right? You earn in the 10th year. That means the interest you earned in 10th year, which also means the interest you earned, you will get at the end of the 10th year.
So if they ask for the 11th year, then you use 10.
10 to the power of 10. Okay. Right. Or we can draw a timeline again, right? So if we calculate, now we're calculating for the balance. Yeah?
We also can find the 10th year interest by subtracting the balance in 9 from the balance in 10.
Yeah. So that's how do we do that? That is, you can tell me, 27 multiplied by 1.03 to the power of 10. That is the balance at the end of the 10th year minus your balance at the end of 9th year. So 2,700 multiplied by 1.03 to the power of 9. How much is that? 2,700 multiplied by 1.03 to the power of 9. We pull that out and put 1.03 minus 1 in the parentheses. They are the same thing. So that is equal to 0.03. Right? Very good. Yeah. Or we can draw a timeline. So using that method, so the beginning balance is 2,700, t equal to 0. And the balance at the end of the first year is 2,700 multiplied by 1.03, right? And the interest you earn from the first year is that minus that, $81. Same thing, t equal to 2. The balance at the end of the second year is that, right? The power to the squared. And at the end of the 10th year is 2,700. 10th. And the 9 here is 2,700 multiplied by 1.39. So that difference is the interest you earned in the 10th year, right? Okay. Question? All right. And that difference is 105.
Fourth year,
Calculate what?
we just calculated 3 years, right? With compound interest rate.
3 years.
Yeah, one, first, second, and third, right?
Oh, we're the third.
Oh, third.
10th.
I'm sorry.
Okay. Okay. Right. Let's move on. Okay, I think it's also simple. If you have 20,000 in an account earning 8% annually, what constant amount would you withdraw each year and have nothing remaining at the end of 5 years? You are withdrawing some a constant amount for 5 years, and end of the 5 year, nothing left. Okay, the initial deposit. Okay, of so there should be a negative, right? But yeah, but we can put a negative to be more, to be more precise. This should be a negative. Okay, so the 5 years, 8% interest rate, and cash outflow, and deposit of 20,000 PMT. We don't know. Future value is 0. Just calculate PMT. It should be that value. Okay. I won't calculate that. It's pretty simple. Right. Okay. Next one. Question on this? No. Okay. Real estate agent mentions that the homes in your price range require payment of $1,500 per month for 20 years. Per month for 20 years, right? Okay, so that is monthly compounding. At 1.25% interest per month, what is the size of mortgage with these terms? The size of the mortgage is the balance at the beginning of the whole period, right? The total initial loan you make, the total initial mortgage you borrowed, right? So that is the present value, okay? And the number of periods, this is the monthly payments. They are 20 years multiplied by 12, okay? And the interest rate is 1.25 interest per month. That's not annual rate, so that's a monthly rate. So you can just put 1.25, okay? And periodic payment $1,500, and no balance, okay, due at the end of the 20 years, okay? Okay, so calculate for PV. So it should be 8, okay? Okay? Right. Uh-huh.
Made everything the whiteboard.
You erase a little bit? Okay. Okay, thanks. Okay, good. Okay. Okay, next one. At what rate must $500 be compounded annually for it to grow to this amount in 10 years, right? Okay, so $400 is the present value and $700 is the future value. For 10 years, there's no periodic or recurring payments in between. Calculate for interest rate, okay? So we are just calculating for different variables in these questions, okay? Okay, go forward. So if you earn 8% per year for a bank account, how long will it take? Now we're calculating for N, okay? It can take it to double, okay, 250 to 500. Okay, there's no periodic payment, 8% interest rate, and annual compounding, so it's 9. Professor Malcolm may have taught you rule of 72. Do you still remember that? Rule of 72. So rule of 70 means the number of periods, the number of years it takes for some amount to double is equal to 72 over what? Interest rates, right? And the interest rate is 8. So 9. 9, okay. So that's rule of 72. Rule of 72 sort of calculates the number of periods it takes for some amount to be doubled. Okay, it's 72 divided by the interest rate in percentage. Okay, 72 divided by 8.
Can you repeat that one more time? The 72?
Yeah, the rule of 72 is the approximate number of periods it takes for a certain amount to double is equal to 72 divided by the interest rate in percentage. Okay. All right. Have you learned the constant growth perpetuity? No? So we skip that. Okay. This is not constant perpetuity anymore. It's not a constant payment. For each payment, for each period, the payment increases at a same rate. So we skip that. We don't need to learn that. Okay. It will be not be tested. Okay. How much more is a perpetuity of $2,000 worth than an annuity of the same amount for 30 years? Okay. Assume an annual interest rate of 20% and cash flow at the end of each period, given annual compounding. Okay. So pretty simple. Well, sorry. The payment, the present value of perpetuity is $2,000 divided by the interest rate, 0.2, right? 10,000. And the annuity, okay? Just plug in the number to the calculator. 30 years and $2,000 for each payment, okay? And interest rate of 20%, okay? And calculate for what? Calculate for the present value. This would be a question mark here. We're calculating for that, and that is equal to $9,000, $9,900. Okay, right? Okay, yeah. And how much more? We just multiply that. Subtract the 9,900 from 10,000. This is a negative sign, doesn't make any mathematical sense. It's just a cash outflow, right? We should put, we should put a positive here. It's negative. It's just, it's just an outflow. It doesn't matter. So you just subtract 9,900 from 10,000. Okay, it's about $42. Okay, all right. Question? So you're going to pay $800 in an account at the beginning of each 20 years. Though that is what? Annuity due. Right? You are going to pay $800 to an account at the beginning of each year, right? And the account will be then be left to compound for additional 20 years. At the end of the 41st year, you will begin to receiving a perpetuity from the account. If the account pay 14%, how much will you receive each year from the perpetuity? That is a hard question, right? Again, what timeline? I have seen these questions in many midterms. Many professors like this question because it sounds like it combines different things together: cash flow, perpetuity, annuity due, everything put all together. All right. So what's the cash flow? T equal to 0 and T equal to, say, 20. T equal to 19. T equal to 21. All right, and something happened around the T equal to 40 or 41, right? Something right here, 42. Okay, we'll just put those numbers. Okay, now you're going to pay $800 for 20 years, starting from now, at the beginning of each year, right? 20 payments. When is the last payment? T equal to what? 19, right? This is the last one. So in between, there are 20 payments, okay? and you leave this account to compound for an additional 20 years. And at the end of the 41st year, you will begin to receive a perpetuity. So the end of first year is when? 41st year. End of 41st year. So remember, so the end of the first year is 1, right? T equal to 1 is the end of the first year. T equal to 2 is the end of the second year. So T equal to 41 is the end of the 41st year. Okay, right? It's right here. At the end of that, you're beginning to receive a perpetuity of some amount. Let's say it's PMT. And it goes on forever. It goes on forever from that on. Okay, from T equal to 41. It goes on forever. All right. And the question asks, how much is that value? Okay. So we may have different methods in your mind. Let's talk about my method. See what's going on here. I'm first calculating the present value of this annuity due as of T equal to 0. Okay. And I do what? Well, this is, okay. Okay. If you want to, in this case, you want to either turn the setting into beginning of the period, or like what we said, calculating the present value assuming it is ordinary annuity, and multiplied by 1 plus R, right? 1 plus R is 1.14, right? Okay. So I'm not going to do this. Maybe I can repeat how to change the setting. Second, begin. Second, enter. Okay, that turns the setting into that. Okay. All right. All right. What? Okay. So let's calculate that. So 20 years, 14 interest rate, and it's a future value. All right. It's annuity due, and we can use the function to either calculate present value or future. I don't know if you can understand this. We're plugging the number, but we're assuming the present value of 0. We're calculating for future value. You can split this into two parts. First, calculate the present value first, and let it compound for 20 years to a future value. Okay, so this seems a little complicated, but okay, let's use this method. I'm not very comfortable with. We can try alternative ones. Okay, now this annuity due. What we do first is calculating the future value of that annuity due as of what? As of the end of the 20th year. I like this method. Okay, the future value right here, and let it compound. Let that value compound for 20 years. To where? 20 years, that's the first year. 20 years, that's it right here. That's future value 1, that's the future value 2. So that is the future value of or the present value of that PMT, of that perpetuity, right? Okay, are you following me? No? Okay, never mind. Okay, now let me repeat this. So it's annuity due. It lasts 20 years. After this annuity due, we are paying 20 payments. We let it compound for 20 years. So at the end of the 20th year, we should have some balance on our account, right? So that is the future value of that annuity due at the end of the 20th year. And we let that compound for 20 years. So we got some value as of t equal to 40. And and based on the question, that should be equal to the present value of that perpetuity as of t equal to 40. Okay. What I was thinking is, if we first calculate the present value as of here, and let it compound for 40 years to here. So we are transfer the money across the timeline. There are multiple methods to do that. But I think this is more intuitive. We are making some deposit. At the end of that period, the depositing period, we have some balance. We let that balance to compound for additional 20 years and get some present value, and starting receiving money whose present value should be that. Okay? All right. Then let's come back to the calculator. Okay. So we just said it's beginning. So that's 20 years. It's a 14%. 0 present value, initial investment, right? There's no initial investment, but $800 negative PMT, and calculate for the present to the future value. Okay, that is as FV at the end of the 20th year. Okay, any question on this? Yeah.
So then the future value that you get on the 20th year, like from the payments that you're making, that future value, when you put it in as present value, does it go in as a negative? The compounding 20 years?
The negative of what?
The second part, where you're just compounding it without making any payments. When it goes in as the present value, is it negative or positive?
Yeah, here is it doesn't matter because this one inflow, one outflow. To be more precise, that should be what? That should be another inflow, right? You are making that investment again. You're putting your money back to the account again, and make this another investment which lasts 20 years. I would say, okay, this can be a negative, okay, but mathematically it doesn't matter that much, right? If that's negative, right, this should be a negative, right, and this being a positive. Okay, so at the end of the 20th year, t equal to 20, we have $83,000. And we let that $83,000 compound for another 20 years. Let that amount compound for another 20 years, and get another future value at the end of the 40th year here. And that should be the present value of the perpetuity. So that should be the present value of a perpetuity PMT divided by 14%. So PMT is just equal to that number multiplied by 0.14.
For the second step,
Equal to 1? 21. Okay, let's count. Right, that's a very good question. Why it should be 21? Are you thinking the 83,000 should be as of t equal to 19? Right, that's a very good question. We call that annuity due. And annuity due means what? Means, okay, so we are having 20 payments, and each payment is made at the beginning of that year. Okay, then we are talking about the last payment, the 20th payment. It is made at the beginning of the 20th year. And we let it compound for 20 years, right? But we don't start from the beginning of 20th year. We start from the end of this compounding, the first compounding period, or the payment period. We're starting from the end of the 20th year, right? So the future value we calculate using this function is t equal to 20. Now, t equal to 20, and compound for additional 20 years. 21 the first year, 22 the second year, 40 should be the 20th year, right? So the difference between two is 20 years. So it should be 21, shouldn't be 21. I think you are saying 21, you are adding this period. But in this period, we are still in the period of investing, putting in money.
Yeah, but 21 is the end of the first year, right?
End of the first year. 40 should be the end of the 20th year, right? So count it. Should be right? Okay, 1 is the first year. 30 is the end of the 10th year. 40 is the end of 20th year, right? So count it. So be careful with this. Okay. All right. If you still don't understand this question, we can discuss after the session. We are approaching the end of the session, and we still haven't finished chapter 5. It seems I can just quickly go over the slides, and if you have questions, you can either email me, okay, or schedule a time that you can stop by my office, okay. We can't finish this. So comparing annuity due to ordinary annuity, annuity due will always, okay, right. Will always have higher both future value and present value, right? That's the formula we just saw. They will have both higher present value and higher future value, right? Okay. Because what? Because each payment is made one period earlier, right? They are closer to the current time. Okay. All right. Yeah. Yeah. Sorry. Yeah.
Will the question be like this as well?
I don't know. I'm not a professor. I hope so. So it's worth to be here today. For everyone, right? I hope so. These questions are from either test bank or previous midterms. That's what I can say, right? From your professors, right? Some of your professors, okay. All right. 49. The present value of annuity stream of $1 per year is $6.14 when valued at 10%. By approximately how much would the value change if these values are maturity annuity due? Okay, so we just calculate the present value of that annuity due and subtract. Okay, so the present value of annuity is how much? Is $6.14, right? So the present value of if this annuity due, it should be 1.1 multiplied by that, right? And just divide and multiply, and then we just subtract 614 from that. So that's the difference.
Wait, 1.110 times 614.
Yeah.
614.
Minus 614, right? The present value of an annuity is 614. So the present value of annuity due should be 1.1 multiplied by 614. Okay, how much difference between the two? That minus 614. Okay, so the answer is 61, right? Okay, 61.4.
So the answer would never be exactly what we have. It will be always an approximation.
Most of the time, yeah. Right. Yeah. It should not be very far away. Well, it doesn't harm to ask your professor. Professor, I'm not sure in this exam. I'm not sure if this. You can ask. Okay, if the number you gave, the options you gave in this question are approximate numbers. If you're getting a different number, confirm with him. If he said, okay, it should be an exact number, then that means you're wrong, and you should spend more time on that question. Yeah?
So that the stream of $100 has nothing to do with the question.
Nothing to do with the question, right. Yeah. Okay. 50. An investment offer to pay $500 a year forever at the end of year 3 if the interest rate is 5%. What is the investment value today? Okay, again, there are multiple methods to do this, and let's do a calculator one. We can use calculator, or you can calculate by hand if your professor taught you that. But let's use a calculator. So it's a perpetuity. The first payment starts from the end of the 3rd year. So timeline again. Starting at the end of year 3, so start from here, right? $500 and go on forever. And you're calculating the present value of that perpetuity as of now. But let's first calculate present value as of here, right? So that is $500 divided by 0.5. 10,000 as of here. But we are not interested in the 10,000 at over here. We are interested in the value right here. So we discount that $10,000 by 2 years using interest rate of 5% to a value as of t equal to 0. Right? PMT, no PMT, and do that. Okay. Right. So you get some sense, right? When you are calculating the present value of a perpetuity or ordinary annuity, we are calculating the present value 1 year earlier than the first payment date. Okay? Yeah. Okay. Yeah?
It's not 3 periods.
How can that not be 3 periods in here? Yeah. Right?
At the end of year 3.
At the end of year 2. That 10,000 is where? Is right here. I just said the value, the present value the present value is 1 year earlier relative to the first payment date. So that 10,000 is right here. So we discount it back by 2 periods. Okay. Even though the first payment is made at the end of the 3rd year, we are calculating the whole present value as of right here. Okay. The divided 500 by 500 divided by 0.05. Yeah. Yeah. Okay. Question? No.
Manually.
Manually? All right. I'll quickly go over this. If you can't remember, you may want to watch the video again. So the present value. The present value of that perpetuity with the first payment not from 1 year from now, it's from n years from now. Think about this. Is the difference what? Is difference between a perpetuity with the first payment that happened 1 year from now minus the present value of an annuity with just 2 payments. Right? Let's say, okay, the present value, oh, I shouldn't have erased that. Okay, so the first payment here, right, 500 from now on. The present value of that whole thing is what? Is the present value of this whole thing minus the present value of these 2, right? So just subtract the 2 securities. Let's just imagine there are 2 securities. Okay, the first one, so the perpetuity with the starting value of 500, as of here, is 500 divided by 0.5, and minus the present value of those 2. It is 500 divided by 1.05 minus 500 divided by 1.05 squared. That 500 divided by once, that 500 divided by discounted twice.
Why wouldn't you add those in? Usually when you add the cash flow.
Now you are subtracting that. Actually, you're receiving all these, and you imagine there are another 2, which are extra, which doesn't exist at all. But now let's assume there are this, so we can calculate the value of that perpetuity, that imagined perpetuity, as of t equal to 0. But that's overestimate, right? They're overestimation. There were 2 extra cash flow that don't exist at all. We subtract the present value of that. Okay, use whichever one you are more, confident at, or comfortable. Okay, all right. Question? Oh, okay. Okay. 51 with APR on a loan that charges interest rate at the rate of 2% per month. 2% per month, and it's monthly rate, monthly compounding, right? So the APR is annual compounding, assuming simple interest. So just 2% multiplied by 12, 24%, okay? It's simple enough, right? So 2% per month, and there are 12 months. It's a simple interest rate, 12 multiplied by 2, okay? All right. The APR and the EAR is you are applying this formula, right? 1 plus EAR is equal to 1 plus APR divided by M, which is compounding frequency, semi-annual payments, right? And to the power of m. So what is the EAR if the EAR is 14.5% and semi-annual compounding, what is APR? So we are just using that number, using that formula, okay? You can calculate that by hand. And you can also calculate using calculator. So let's see how to do that, okay? There are 3 variables. One is the EAR, the other APR, and third is M, okay? Second, there's I, C, O, and V, right? Click that. And if you keep it down, there are 3 variables. Nominal, effective, and CY, that's M. Okay, there are only 3. So you enter 2, and you can calculate the last one. So for this question, we know 2 variables. The first is the EAR. Put EAR 14.555, enter. Click down. And how many? 2, right? Semi-annual. M is equal to 2. Frequency equal to 2. Down. Calculating for nominal or APR. Calculate. 14.009. Yep. Question?
Yes.
Question? Okay, good. All right. Same thing here. Now we know APR. Yeah?
Icon, do you need to change back?
No, you don't need to change back. Right, so for the next question, you just input the 2 variables, maybe 2 different variables, right? And calculate for the third one. Yeah. You don't need to clear anything or. And nominals are APR, EFF is EAR, and IY is M. It's frequency. Okay. Okay. What is annual compounding interest? What is EAR if we know that? Okay, we can do those again. I'm not gonna repeat it. Okay. Again, same thing. There are 2 investments. Investment N yields 10% APR quarterly, so we can calculate for its EAR, right? Right. So the nominal is 10, IY is equal to 4, and the EAR we can calculate that. And the investment B yields the same compounded effective rate. So R should be that. We plug in that number for investment B and calculate for B's APR. So here are the 2 steps. The first thing we calculate the EAR for investment A, and the question said both investments have the same equal annual rate yields. They have the same EAR. So we plug in the EAR of A to the EAR of B and calculating for the APR of a B. Okay, a little more tricky, but still you're using that function, right? Calculator function. Okay, all right. Question? More a little well, it's yeah. Okay. All right. Next one. What is the present value of the following cash flow? Have you learned the complex cash flow? No, not yet. It's not going to be tested. No, we skip it. So it's like you receive $100 in the first year, $200 in the second year, $3,000 in the third year, and what's the present value? No, okay, let's skip it. Let's leave it for the second review session or the last one. Could be tested. Okay. If you are interested in that, you can ask me after session. Okay, we got 20 minutes left. Miller's, okay, plan to save on, okay, it's complex. Skip it. Yeah.
My question is
52. That one? Is the number correct? It should be correct, right? These are the correct question number. Yeah. Okay. Okay. Yeah. Yeah. Let's finish this. The last one for chapter 5. If the interest rate is 5%, which of these investments would you prefer? You would prefer the one that gives you the highest present value. Okay. These are different cash flows. Ordinary perpetuity, $30 per year, so present value 30 divided by 5%, right? 600. A payment of, okay, that today, so that's the same number, right? Same present value, same amount. A single amount of $500 at the end of first year, so okay, $500 divided by 1 plus R, 1.05. Or the last one, a payment of that for 20 years at the starting in 1 year's time. That's ordinary annuity, right? Which lasts 20 years. Okay, 20 years, 5% interest rate, $50 payment, 0 future value and present value. And it seems that is the highest one. Okay, all right. Whew. So that's the math part. All right. If you still have questions, you can ask me after session or email me or stop by my office. And let's go to the other 3 chapters. Yeah, 4 chapters.
So where expenses, how far?
The top line, yeah. Okay, give you 5 seconds. Okay, 2, 1. Okay, yeah. So the chapter 2 is financial markets and institutions, intermediaries. Chapter 3, accounting, and so chapter 2 is just institutional background. What are financial markets? What are financial intermediaries? And within financial intermediary, what are the financial institutions? And the chapter 3, finance and accounting, you're going to learn. How many of you from accounting major? Balance sheet, income statement, right? You talk about that every day, and cash flow statement. And chapter 4 is ratios, how to measure the performance of a firm using all kinds of ratios. The performance, the profitability, the liquidity, the debt service ability, right? All these ones. Let's quickly go over. I would recommend you to use these slides as an outline to read the textbook. Make sure you guys, you read the textbook, spend like a few hours to read those things. Very helpful. Yeah? Yeah? Yeah, right after the session. Okay. Okay, start from chapter 2. What is a financial market? It is a market where financial securities are traded, right? Stock and bonds and derivatives and commodities, right? It's securities where it's a market where financial securities are traded, and there are different categorizations of financial markets. It could be categorized based on whether the security is newly issued. If it's newly issued, we call it a primary market, right? If stock goes by IPO, it first goes to the primary market. And then if it's not newly issued, it goes to the secondary market. If we as investors are trading stocks every day on a daily basis, most of us are working on the secondary market. Or you can bidding for an IPO and get that share. And if you successfully bid on it, you are actually transacting on the primary market. Okay? Or we can categorize them by the nature of the security. They could be equities, they could be common stocks, or they could be fixed income, say bonds, right? Or commercial papers, or derivatives, okay, futures or options, okay, or foreign exchange, like foreign money and commodity markets, okay, the nature of the security, or the maturity of the security. If this is a security with a maturity less or equal to 1 year, we call that money market. If that market are trading security with mature securities with maturities longer than 1 year, we call that capital market. So money markets are like a short term, right? We call it commercial paper. These are the debt, short-term debt issued by the firms, corporations, to borrow money to fund the daily operations. Okay, daily operations like buy inventories and pay short-term debts, these things, right? These long-term ones were what? Stocks, right? When does a stock expire or mature? Never, right? A stock never mature as long as the firm still exists, right? Still exists. Or bonds, right? Bonds, they have maturities of 5 years, 10 years, 20 years, 30 years. As long as it's longer than 1 year, we call that the bond is traded in capital market, okay? All right. Now, financial intermediary. Financial intermediary is an organization. It's not a market anymore. It's like a stock market is not an organization. It's just a market where investors trade with each other, right? But now financial intermediaries, they are real organizations, which not only brings the investor and borrower together like financial market. They have some other functions. other than bringing everyone, investor or borrower, together. And we're going to talk about a little more about that. So they are organizations that raise money from investors and provide financing for individuals or corporations or other organizations. Let's see some examples. Financial intermediaries, mutual fund, or hedge fund, or pension funds. Okay, read those carefully after the session. Okay, so they have different characteristics. Like a mutual fund is an investment company that pools the savings of individuals or corporations and use their expertise to make investments by picking the right stock to beat the market. Okay, what they do is picking the right stock, the undervalued stock, and beat the market. Yes. I'm gonna upload it to Blackboard. This is the third time I said this on the session, right? The third, fourth time? Yeah. Okay. Right. Okay. It's a low cost. Okay. Say you want to buy S&P 500 index, right? Some of you may have been trading stocks, and it's very costly for you to use your deposit, say $2,000, to buy 500 stocks. It's impossible. That's very cost efficient if you invest in a mutual fund. They're gonna invest that $2,000 for you. Okay, so you don't need to be a wealthy individual. You don't need to be like a corporation. You can be just as a student, individual investor. Okay, you don't need to be very wealthy to be able to invest in a mutual fund. They beat the market by picking good stock. The fee is a percentage of the portfolio value and less related to the actual performance of the mutual fund manager. So the manager is compensated based on the size of that portfolio by attracting investors. Okay, investors not necessarily being wealthy. Okay, a hedge fund is a private investment fund that pursues complex, high-risk investment strategies. From these things, it's pretty intuitive that it's not for individual or ordinary investors like this, because they're very risky and the trading strategy is very complex. Okay, and investors are supposed to be knowledgeable investors, such as pension funds, endowment funds, or wealthy individuals. Okay, and the fees or the compensation that those managers earn is less related to portfolio value. It's more related to the performance, the actual performance they make. Okay, they charge a percentage of the performance they earn each year. Okay, and pension funds, we all know that, right? As employees, the employer are gonna collect the money from you annually on an annual basis and save that for you and then make long-term investment and wait until you retire and pay you back, okay, periodically, okay? And designed for long-run investment because that's designed for your retirement. And they have tax advantages, meaning that each year's your contribution to the fund, okay, is tax deductible, okay? You can reduce your tax payment if you make these contributions into a pension fund. And the tax will only be charged when you are actually withdrawing money from the account when you actually retire. Okay, it will not be taxed if you are not withdrawing any money. Okay, so it's tax deductible and tax advantage, right? Okay, and in financial institutions are just a type of financial intermediaries that does more than just a pooling and investment savings, like what a mutual fund or hedge fund or a pension fund does. So they could be commercial banks, insurance companies, investment banks. Okay, they raise money in different special ways. Banks, they raise money by absorbing deposit, and insurance companies absorbing by selling by selling insurance policies, right? And investment banks, we're going to talk a little more about that. So provide individual financial services. Banks provide us a lot of financial services, right? Also insurance firms, insurance companies. They not only invest in securities, but also lend money to real assets. Right? So banks, they lend money to real companies, firms, right? Real assets, individuals, businesses, or organizations. Not like a mutual fund or hedge fund. They usually only invest in financial securities like stocks and bonds and derivatives. Financial institutions, they can invest in the real assets, in real individuals, businesses, organizations. Okay. Commercial banks, the major source of funds, major sources of loans for corporations. Corporations, when the firms want to borrow money, they go to banks, commercial banks. Okay. Investment banks. Okay. Many smart people in there and advisors and portfolio managers Okay, they do not generally take deposit or loans. Okay, they do not absorb loans. They advise and assist companies in obtaining finance, like assisting IPO or underwriting stock issuance, and advise on takeovers, merger acquisitions. Doing these like pricing models and evaluations and advising how, either from the financial point of view or from the law point of view, to assist the firms in doing these big businesses, large deals. Offer investment advice and manage investment portfolios for individual and institutional investors. They provide investment suggestions and ideas. Okay. You can read this. They have trading desks. They have like their own money in like an incubator, right? You see, you can observe some startup firms, startup companies. They are angel round funding or A round, or B round funding. Most of these money are from investment banks. Okay, all right. Or insurance companies, they are more important than banks for long-run financing. Okay, because they are supposed to be for the retirement, right? They often make long-term loans directly to corporations. The money they make, the money to make the loans come mainly from the sale of insurance policies. Functions of financial markets and intermediaries, there could be multiple choice questions, right? Which of the following is not a function of financial intermediaries and institutions, right? Transfer cash across time, right? Your deposit, your cash account, check accounts or saving accounts, right? You can move your cash flow across the timeline. Or risk transfer diversification, you do not need to directly invest in that firm. You deposit money into a bank, and the bank will utilize their expertise to invest for you and make the diversification for you, right? So your risk is diversified and transferred. And provide liquidity. Your checking account is you can withdraw money, or if you are a mutual fund manager, you can write checks using your holding on the mutual fund. So these all provide you liquidity. Payment mechanism, right? Credit cards, right? So these are payment mechanisms. Information provided by financial markets, we can observe prices, commodity prices, natural gas, oil, right? Metals, right? And the interest rates on the bond market, we can see how costly does a firm need to finance their projects, right? And company values, stock prices, cost of capital, right? So the firms can evaluate the cost of raising actual capital from the stock market or from the debt market. So with the financial markets intermediaries, we can have all these functions. Read the textbook, read the detail, and it could be multiple choice questions, right? So yeah, that's what I can see. So let's quickly go over these questions. What is the primary distinction between security sold in primary, second market? Whether it's a first issuance, right? Whether it's newly issued or already exist. Ultimately, it comes from where? The depositors. Okay? The financing, corporate financing comes ultimately from savings by households and foreign investors. Okay. Which of the following are both a financial intermediary and a financial institution? Yeah, insurance companies, commercial banks, investment banks. Okay. Money market, commercial paper. Common stock never mature. They are longer than 1 year. Commercial paper are less than 1 year, right? This type of financial institution generally does not accept the deposit, but does underwrite stock offering. Okay, IBD, right? Investment banks. Yeah. Which of the following is not typically considered a function, right? Investing in real assets. Okay, is not considered a function of financial intermediaries. Okay. Some financial intermediaries, they don't invest in real assets, right? Like mutual funds and hedge funds, pension funds. Okay. But all the others are the function. One reason suggesting that banks may be better than individuals at matching lenders to borrow is that banks, they have the expertise of choosing projects. They have better information than us, depositor, to choose the profitable projects. Okay? They have information to evaluate creditworthiness. Right? Okay. Which of the following function does not require financial markets? Retention of cash by corporations, right? Corporation, they create profits each year. They can just keep that, right, as a retained earning if you are counting. Retained earning on the balance sheet, they do not require financial markets to achieve that. But all the others are liquidity, diversification, risk transfer, and price information. opportunity cost of capital. Have you learned this? Yeah? Okay. Definition. The minimum acceptable rate of return on a project. Okay. By definition. Excess cash held by a firm should be what? Should be invested in the project offering rates of return higher than the cost of capital. Not A, right? Highest rate of return. Even if it's the highest, it could be lower than the cost of capital, right? So we should choose those returns that are higher than the cost of capital. Which of these parties cannot invest in the hedge fund? Okay, small retail investors. Okay. Pension fund, these are large institutions, wealthy individuals. They can. Which of these parties can invest in the mutual fund? All of them, everybody. Okay. Small, large, wealthy, not wealthy. Which one of the following funds provide tax advantage? Pension, right? Pension funds. Chapter 3, accounting and finance. We know 3 tables. Okay, a balance sheet is a financial statement that shows the uses of funds, funding, or finance, and the sources of the firm's funding or finance. Right. The uses are the balance on the asset side, and the sources are the liability or the equity side. Right. Okay. Assets. It could be current assets with maturity less than 1 year. There are inventories, receivables, marketable securities, or cash. Okay? Or long-term fixed assets. These are equipment, plants, property. Okay, long-term ones. And it could be tangible or intangible. Property, equipment, or plants that are tangible. Or they could be intangible, like the management skills, or your brand value, right? Or your teamwork, the value of your cooperation, the team. Okay? These are all intangible. Okay, these are still assets to your company. Liabilities, they represent the sources of that funding. Okay, it could be from a debt or from equity, right? Okay, and all items in the balance sheet are expressed as a percentage of a total cost. These are what? These are called a common side balance sheet. Common side balance sheet divide all items on the balance sheet by total assets. Okay, so that's a sample of a balance sheet. I recommend you memorize these. These are examples of current assets, and these are examples of fixed assets, current liabilities, long-term liabilities. They should be equal, right? Two sides should be equal. Did you learn this? Net working asset, net current assets, or net working capital is difference between net current assets and the current liability. Okay, it measures a company's potential reservoir of cash. Current assets are those assets that can be easily transferred to cash if you need them. And the current liabilities are those liabilities or debts, liabilities that you owe in a very short period of time from now. Okay, and the difference between the two is your reservoir of cash. Okay, you can make control. Okay, and book values. Balance sheets are based on book values. They are historical values. They're backward-looking. They are measured based on the real cost, the historical cost of those assets or liabilities. Okay, and market values are those the current values of asset liabilities that you can observe on the financial market. Okay. Income statement is a financial statement that shows the revenues, expenses, and net income of a firm over a period of time, either a quarter or a year. Right. Common size income statement divide all items by sales. Okay, by sales, and that's a sample. Net sales minus cost of goods sold minus administrative expenses, depreciation, and it is equal to EBIT, operating income. That's very important, right? Operating income. Operating income minus interest expense, and it is equal to EBIT minus interest expense is equal to the taxable income, and you pay tax on top of that, and that is equal to income. And that is the money left for the owners of the company. And the owners are the equity holders. They can decide to pay dividend out of the net income or just put those money back to the company and make more investment for future. Okay, statement cash flow is a financial statement that shows the company's cash receipts and cash payments. These net income not necessarily stand for real cash flow, right? Some sales, they can be recognized as sales, but you do not necessarily receive the actual money, right? so they are not a very accurate measure of the real cash you receive or pay within this 1 year or this period. So cash statement shows the cash flow. Okay, this is different than the income due to two major differences: depreciation and the cash versus accrual accounting. Right? You all know there's depreciation, right? It's a capital expenditure. You buy a property and depreciate using multiple time periods. Okay, and these accruals are receivables, payables. Right? I'm gonna skip this. Free cash flow. Memorize that. Free cash flow equals to cash flow from operations, which is equal to that, and minus capital expenditure. Based on definition, if we look at the textbook, capital expenditure in the textbook, it is a cash flow from investment opportunity, investment activities. Okay. There are multiple definitions. If you search on Google, there are multiple definitions, but use the one that show up on the textbook just for safety reasons, right? Okay, I'm not gonna do this, and these are very simple questions. Let's go to chapter 4. These are all ratios. Some professor told me he's gonna give a cheat sheet, but I see some ones don't have cheat sheet for the exam. Let's quickly go over it. You still need to memorize that. Market value added is the market value that is the actual value created by the corporation on top of the initial investment. Okay, market value of equity minus book value of equity. Or you can divide the two, right? Get a ratio. Yeah, question? Profitability, ROA. So this is ROA and ROE. Compare the difference. One is after-tax operating income. It's not net income, right? Net income is for ROE, okay? Because net income is left for the equity holder. But this after-tax operating income is both for debt holder, liability, and equity, okay? Total assets. So these two should be corresponding. And turnover and the EVA, this is important, okay? This is the opportunity cost of getting the capital. The opportunity cost, that's the economic meaning, right? Economic meaning, economic profit you make. It's not an accounting profit. Turnover and all these ratios, debt ratio, okay? There could be multiple questions on the liquidity measure. There are some interesting questions. Say a retail store 0 net working capital, meaning current liability equal to current asset. If they are equal, they can have a lower than 1 quick ratio, because quick ratio is current asset minus what? Minus inventory. You minus some part, but divided by the same thing, current liability. So the ratio should be less than 1, value of less than 1. Okay. I won't do all the other questions. You can these are if these are calculations, you can find the steps. If they are conceptual, you can find the answer in your textbook. Okay, do them. I will upload this afternoon to Blackboard. The video can be uploaded by Oliver maybe 1 day or 2 days later. Yeah, right. When is your midterm? Tomorrow? Is any midterm tomorrow? Tuesday, Oliver, so we got a due date. Yeah. Okay, yeah. Any question? So that concludes our first session. Hope it's helpful.